OpenAI launches ChatGPT Images 2.0 with thinking capabilities. Anthropic investigates a breach of the high-risk Claude Mythos model. Google Cloud commits a $750 million fund for the AI agent ecosystem. Let's get right into it, because the rollout of ChatGPT Images 2.0 fundamentally deprecates traditional visual generation. We have crossed the threshold from reactive rendering to active, mechanistic reasoning. The architecture of Images 2.0 deprecates the traditional one-and-done forward pass. In a standard diffusion model, you inject text embeddings into a latent space, and the system probabilistically denoises static until the structural weights align with a statistical guess of your prompt. But what we're seeing now is the native integration of reasoning loops directly into the pipeline. The model effectively pauses the diffusion process to engage a frozen, highly capable large language model. It maps out a deterministic spatial and cultural blueprint before a single pixel is ever rendered. Instead of instantly getting a flawed image back in 1 second, the system deliberately increases latency to 15 or 20 seconds. It pulls real-time context from the live web, updated all the way through December 2025. It actually asks itself, did I parse the architectural constraints correctly? Is the lighting mathematically consistent with the requested time of day? Does this cultural attire match contemporary real-world data? It is essentially running a retrieval-augmented generation pipeline, but translating the retrieved data into spatial bounding boxes. The most striking leap here is how it handles non-Latin typography. Historically, text rendering in AI was an absolute disaster because diffusion models don't actually read letters. They just approximate the visual shapes. When you deal with complex linguistic scripts like Hindi or Arabic, where spatial relationships change based on surrounding ligatures, shape approximation fails entirely. Images 2.0 solves this by actively proofreading its own typographical output against rigid structural linguistic rules before finalizing the decoding. Imagine you are building a highly interactive digital museum exhibit. You have a newly discovered ancient astrolabe, and you need to showcase it mathematically identically across 8 completely distinct architectural environments, from a brutalist concrete bunker to a hypermodern glass dome to a neoclassical hall. The geometry of that astrolabe and the shadows it casts must be pixel perfect across all 8 variations, stretching to extreme aspect ratios like 3:1 panoramas or 1:3 vertical formats. And the informational placards in those environments need to be flawlessly localized in Thai and Arabic. A year ago, that was a multi-week pipeline requiring Unreal Engine modelers, lighting specialists, and localization experts. Today, the reasoning loop handles the geometry, lighting, and typography in a single execution graph. It's like hiring a world-class art director who pre-reads the brief, runs a physical simulation of the lighting in their head, and only then picks up a brush. Now, on one hand, there is a core debate about whether enforcing this rigorous logic kills the serendipity and happy accidents of early AI art. When you decrease the temperature of a model, you do risk sanitizing the output. But on the other hand, these reasoning loops aren't enforcing rigid realism. They are enforcing strict adherence to your parameters. If you mathematically specify surrealism or instruct the model to invert standard gravitational physics, the engine will plan a highly coherent version of that exact surrealism. The burden of serendipity just shifts back to the user. You have to engineer the ambition directly into the prompt. And that demand for intentionality at scale is completely rewriting the economics of visual manufacturing, moving straight from 2D into Hollywood-scale 3D worlds. The premiere of Bitcoin Killing Satoshi at the upcoming Cannes Film Festival is the watershed moment for this shift. It's a major studio feature film utilizing a production model called Human First, AI Finished. The initial script demanded on-site filming across 200 distinct global locations. Traditionally, that balloons a budget to $300 million. Instead, they shot the entire live-action component on a single custom-built soundstage over just 20 days. They retained tactile reality using 107 human actors and 154 crew members for immediate physical props and costumes, but they slashed that $300 million budget down to $70 million by replacing all global logistics with a team of 55 highly specialized AI artists. Those artists used advanced latent consistency models and neural radiance fields to generate massive photoreal environments around the live-action performances. The cost of environmental scale basically just drops to the cost of compute. But when digital reality becomes this cheap to manufacture, human identity suddenly becomes the most vulnerable asset on the board. The threshold to clone a location is near zero, and the threshold to clone a human face is already there. This is exactly why YouTube's aggressive rollout of their likeness detection tool is the necessary counterweight. It applies the exact same hashing and matching logic as Content ID, but it's engineered specifically for the latent embeddings of human faces. It's biometric digital rights management. You don't even need to be an active YouTube creator. Once your biometric facial profile is enrolled, the system runs silent, persistent scans across all new uploads, hunting for AI matches of your face. You can issue a strike, a privacy takedown, or let it ride, with strict carve-outs preserving parody and satire. To grasp the destructive potential this mitigates, imagine a contested local municipal election. A bad actor hijacks the precise facial geometry and micro-expressions of a leading politician, generating a flawless, hyper-realistic video of them aggressively endorsing a deeply unpopular zoning policy. They blast it across hyperlocal social media 48 hours before the polls open. The latency of truth, the time it takes forensic analysts to mathematically prove the deepfake, is vastly longer than the time it takes for electoral trust to shatter. We are transitioning from copywriting content to copywriting biology. The unique topography of your face and the resonant frequencies of your voice are now extractable digital assets requiring enterprise-grade protection. Meanwhile, the intelligence layer is no longer waiting for us to hit generate. We are transitioning from prompt-based reactive chatbots to persistent, always-on autonomous agents, a shift perfectly illustrated by OpenAI's new internal platform, codenamed Hermes. You instantiate a custom agent, grant it specific integration skills, define its goals, and it continuously polls its environment in the background. It monitors state changes in your inbox, parses Kanban boards, and executes workflows autonomously without ever receiving a manual trigger. If an agentic system can natively interpret goals and schedule subtasks, the operating system of work is no longer a static dashboard like Asana or Jira. It migrates entirely into the intelligence layer. While OpenAI is building this for individuals and agile teams, Google is deploying massive capital to wire the entire central nervous system of the Fortune 500. Google Cloud announced a $750 million adoption fund to subsidize third-party integrators. They formed the McKinsey Transformation Group, paying global consulting firms to architect agentic AI using the Gemini Enterprise Stack for legacy clients. The absolute apex of this is the $1 billion contract they just inked to deploy Gemini-powered agents across Merck's 75,000-person global supply chain and pharmaceutical R&D pipeline. But how do they bypass the ultimate security bottleneck? How does a public cloud model safely read a corporation's classified internal data without causing a catastrophic data leak? The answer is BYOMCP, or Bring Your Own Model Context Protocol servers. The MCP server sits securely behind the enterprise firewall, directly on top of the proprietary data silos. When a Gemini enterprise agent needs live shipping data, it sends a highly structured query to the MCP server. The server authenticates the agent using strict role-based access control, translates the query into SQL, pulls the data points, vectorizes them on the fly, and injects them directly into the agent's active context window. The large language model gets the exact information it needs, but the proprietary data is never absorbed into the model's underlying weights. It is a flawless quarantine. Google is essentially subsidizing the massive labor costs to integrate this architecture, because winning the Fortune 500 isn't about reasoning benchmarks. It is entirely about change management and legacy integration. The immediate output of this infrastructure lock-in is already visible with Deep Research Max, powered by the Gemini 3.1 Pro model. It completely commoditizes complex knowledge synthesis. Imagine a team of urban planners overhauling a major metropolitan area. They need to analyze 40 years of contradictory zoning ordinances, structured traffic sensor data, and environmental assessments. Traditionally, that's a team of junior analysts spending 8 months manually extracting entities. With Deep Research Max, the agent breaks the overarching goal down into hundreds of parallel subqueries, essentially running a map-reduce function for agentic reasoning. It correlates geographic constraints against traffic data, reasons through contradictions, and generates a cohesive 100-page synthesized proposal with data visualizations in hours. The economic value of the human worker shifts entirely away from baseline synthesis and strictly to the final high-stakes judgment call based on the AI's output. But building agents that can flawlessly navigate corporate systems requires invasive data gathering, bringing us to Meta's highly controversial Model Capability Initiative. Meta has implemented a mandatory no opt-out protocol that actively tracks the workflow of U.S. employees, recording every keystroke, mouse trajectory, and high-frequency screenshot. The backlash is immense, especially since it started just weeks before a scheduled reduction in force of 8,000 staff members on May 20th. They are strip mining the intuition of their workforce right before terminating them. They are training vision language action models. Imagine a senior cloud engineer diagnosing a critical server failure, toggling frantically between a 3D network model, a live terminal, and a Slack channel. The AI analyzes the exact coordinates of mouse movements and micro-hesitations. It ingests the unstructured pixel data of the UI and maps it deterministically to the engineer's intuitive, undocumented leaps of logic. It's digital motion capture for knowledge work. Training these advanced agentic models, specifically coding agents, requires compute that is fundamentally altering corporate structures. Look at the unorthodox $60 billion acquisition option between SpaceX and the AI coding startup Cursor. SpaceX guarantees a $10 billion investment tied to joint technology development, giving Cursor privileged access to xAI's frontier models and SpaceX's Colossus supercomputer. Training an agent that can write code, test it, realize it failed, and rewrite it requires reinforcement learning from AI feedback. You have to spin up millions of virtual sandboxes and evaluate which programs compile efficiently. Without Colossus, Cursor was facing an existential threat from competitors like OpenAI's Codex and Anthropic's Claude Code. Algorithmic elegance is no longer the primary differentiator. The actual bottleneck is raw metal. As demonstrated by Thinking Machines Lab recently maxing out Google's A4X Max virtual machines utilizing NVIDIA's GB300 GPUs, the capital expenditure required to network next-generation GPUs creates an insurmountable moat. Here is the terrifying paradox of that compute scale. When you deploy all that raw metal to train a coding agent to understand software architecture, it inherently learns exactly how to dismantle it. Anthropic developed Claude Mythos, a model with reasoning capabilities so advanced they deemed it unsafe for public deployment. Through Project Glasswing, they granted restricted access to corporate partners to hunt for critical vulnerabilities. Mythos autonomously analyzed the Firefox 150 codebase and patched 271 distinct bugs. It uncovered a 27-year-old architectural flaw in OpenBSD. But the true alarm bell rang when it executed a complete 4-vulnerability browser exploit chain. It reasoned across the system architecture, found a memory leak, exploited a JavaScript engine flaw, and leveraged a kernel flaw to completely break out of the sandbox. It chained 4 unrelated low-level flaws to achieve total system compromise, and it was never specifically trained on offensive hacking datasets. The reasoning required to verify security is mathematically identical to the logic required to exploit it. Entirely predictably, containment failed. Anthropic is currently investigating a severe breach involving unauthorized access to the Mythos model through a compromised third-party vendor environment. The UK AI Security Institute confirmed that models in this class have successfully and independently passed 32-step autonomous cyber attack simulations. You give the agent a target IP, and it autonomously probes firewalls, pivots around honeypots, and navigates 32 sequential barriers without human input. The window to patch legacy infrastructure has collapsed from years to months. What happens when that reasoning engine escapes the digital sandbox and gets physical actuators? Sony AI just shattered a major barrier with their robotic system ACE, a robotic arm with a 9-camera perception array that systematically defeated elite human table tennis players. The true breakthrough is the training methodology, simulation-based learning, or Sim2Real. If you train a physical arm through trial and error, it instantly destroys the hardware. Instead, you run a hyper-accurate virtual physics engine at 10,000 times real speed, injecting adversarial noise through domain randomization. Engineers randomly fluctuate virtual gravity and aerodynamic drag. By fighting against a chaotic physics engine, the neural network develops highly robust recovery policies. When flashed into physical silicon, it instantly adapts because reality is actually less chaotic than the simulation it mastered. This millisecond-level processing is being miniaturized into wearable AI hardware. Supply chain leaks confirm the Apple AirPods Pro 3 and Sony WF-1000XM6 are integrating dedicated AI neural processors directly into the earbud silicon. This is the critical pivot from cloud AI, which is latency-bound, to edge AI, operating in real time. By utilizing advanced model quantization, engineers are compressing billion-parameter neural networks to run locally on a 10-milliwatt chip. Unlike traditional digital signal processing, an edge-based neural processor understands the semantic structure of sound. You can stand on a deafening airport tarmac, and the AI actively suppresses the unstructured noise while perfectly isolating the vocal biometric signature of a colleague 3 feet away. The AI interface becomes invisible, actively editing your perception of the world in real time. Dominating that edge silicon requires a radical realignment. After 15 years, Tim Cook is stepping down as Apple CEO, handing total control to hardware chief John Ternus on September 1st. Cook built the ultimate refinement engine, guiding Apple to a $4 trillion market cap. But critics say Apple missed the software layer of the generative AI war. Elevating a 25-year hardware veteran signals that Apple believes the existential war of the next decade will be won in physical silicon, not cloud software. The stakes get infinitely higher when these physical AI models are applied to human biology. Biotech startup 10x Science just closed a $4.8 million round to attack the massive bottleneck of drug validation. Traditional AI is proficient at predicting the static 3D structure of a protein like AlphaFold does, but a static snapshot doesn't tell you how it moves. 10x Science utilizes advanced dynamical systems modeling to map the kinetic energy landscapes of proteins folding over time. Their AI outputs a transparent, mathematically verifiable proof of why a generated drug will bind to a microsecond window site, bypassing multi-year clinical dead ends by simulating biological kinetics in the latent space. We are compiling the source code of human biology. But this brings us to the ultimate contradiction. We are handing highly complex AI architectures the keys to biological validation, global supply chains, and cybersecurity. Do the human beings actually in charge of these corporations understand the systems they are deploying? A conference board report indicates that 83% of S&P 500 companies now officially classify AI as a material risk, yet only 2.7% of the directors sitting on those boards possess any actual technical AI expertise. A USC Viterbi study exposed this perfectly. Advanced AI models interpret qualitative uncertainty terms like unlikely using entirely different mathematical distributions than humans do. Imagine an agent managing the Eastern Seaboard power grid. It detects an anomaly and reports that a cascading blackout is unlikely. Human operators assume that means a negligible 5% risk and authorize the current load. But the AI model, mapping language strictly to latent space probabilities, defined unlikely as a rigid 49.9% probability. The human authorized a coin flip on a catastrophic blackout simply because they didn't understand the model's mathematical language. As system intelligence scales, human capacity to accurately govern it is rapidly degrading. Before we get into the final takeaways, just a reminder that you can find more insights like this at inuku.com. Let's synthesize what all of this means for you. First, physical AI and robotics are advancing aggressively beyond software. Simulation-trained systems are ready to automate real-world chaotic environments. Second, enterprise AI deployment is no longer about chatbots. It's about building secure, agentic infrastructure that embeds directly into legacy databases. And third, AI drug discovery is pivoting from hallucinating static molecules to mathematically validating dynamic biological interactions in a latent space, shifting pharmacology to an engineering discipline. But underneath it all lies a massive governance crisis, where corporate leadership is fundamentally misaligned with the mathematical reality of the tools they are deploying. And that's your daily dose of AI know-how from Anuku.com, AI news you can use.